Yes, of course you could be wrong. Because that guy can exist down here. He could exist on this curve. Is it more likely he's on this curve or this curve? Null or research? No. But based on this curve, it's more likely he's up here. But remember, this little son of a bitch can slide side to side. We don't know where the center is. So is it possible that we slide it far enough this way that the height's actually higher here than it is here? That's the problem with calculating type 2 error. You have to know where that is before you can do it. This is fixed at 5%, so our type 1 error is always at 5%. Beta shifts depending on what you put here. That's a horribly tricky idea right now for us to internalize, and we're not going to. All I want you to do right now is be able to tell me the two ways that you could potentially be wrong. The first is a type 1, where you say something has changed when in fact it hasn't. That's a type 1 false positive. A type 2 false negative is that you say something hasn't changed when in fact it has. Keep that in your head right now. That's what I want you to keep in your head right now. What's the chance of a type 1? Always? 5% if we're at 95% confidence. What's the chance of a type 2?
No idea.
Good! Good! We have no way of calculating because we don't know where this curve is. It's shaped similarly to this one, as far as height and width and all that, but we don't know where it is center-wise. And that's, so this little distance right here can actually change based on where we assume that center to be. Keep that in the back of your mind. Christian, you look troubled. Ask me that question. Just take it all in.
Yeah,
get comfortable on that nice hard concrete wall.
That way none of it comes out.
Oh, good. There's an eggs in the back of your head. I'm sorry. Sorry to hear that. Is this fair? We're going to revisit this diagram probably on Tuesday. But this is a good start. Realize there are two curves. There are two curves. You know where that one is because you put it there. This one can move. This one can move. Hell! Could it be over here? Could it be over here? If it were over here, what's actually going on? Right. You're inhaling secondhand smoke. And your lungs are actually getting better. So it could be over here. I'm not saying it's very likely. Now, realize too, this curve goes over there. Its tail goes over there. It's a very small tail at that point, but it's still there. It's still there. So realize you don't know exactly where that curve is. All right. Let's synopsize. Let's synopsize. Let's synopsize. I think I'm using that word correctly. Am I using that word correctly? Is that a real word? Let's summarize. I'll put another one to it. Let me explain. There is no time. Let me sum up. Princess Bride, please tell me some of you have seen that.
Yeah.
Okay. That's more hands than I'm used to seeing. And my younger class is like, what? Why are you talking like Spaniard? Okay, so here's the big takeaway. Here's the big takeaway about error. If you get a small p-value and react appropriately, what the hell does that mean, react appropriately? What is an appropriate reaction to a small p-value?
You got something you weren't expecting.
Good. So what are you going to say? Something changed. Awesome. You got a small p-value. You got something you weren't expecting. Perfect, Karen. So back to our graph. You were expecting this. You got this. So you're going to believe H1. Whatever is in H1, you believe it. So you believe secondhand smoke decreases lung function. You believe my deck of cards is rigged. Remember that?
I did.
Some of you did. Some you didn't. You said to hell that it could happen, right, Gary?
No, I believe you.
Oh, you believe that it was rigged?
You lied to me.
Oh, so you say I lied to you. So even though I didn't make a claim, I didn't actually make a claim. I said describe this deck of cards. You guys were the ones that lied for yourselves.
Okay.
Man.
You got me there.
But so that's what an appropriate reaction is. An appropriate reaction to a small p-value is that I don't believe the null hypothesis. I'm going to reject the null hypothesis and believe whatever is in H1. That's my appropriate reaction to a small p-value. You could make a type 1 error with probability little alpha, and we're going to set that right now at 5%. I want to come back. I didn't answer the 99% question that somebody asked earlier. I'm going to come back to these curves and show you what I'm talking about there. Fair enough? Go. Get a large p-value and react appropriately. Okay, so let's talk about what an appropriate reaction to a large p-value is. Okay? Appropriate reaction to a large p-value. Go ahead, say that again.
You say something changed.
Oh, don't do error right now. You run the original test and you get a big p-value. Where did you land?
Where you expected to.
We landed in blue, where we were expecting to by the null. So therefore, what's the appropriate reaction?
You believe in null.
Believe whatever's in the null, say nothing happened. Nothing happened. I was expecting lung function to stay the same or increase. It either stayed the same or increased. Nothing out of the ordinary happened. I believe the null. Could you be wrong?
Yes.
Of course, you said nothing changed when in fact it may have changed and you missed it. More on that in a second. Ashley, go.
Got it.
Are you sure? Awesome, awesome, fantastic. I love hearing that. Susie.
So would you then be rejecting the research hypothesis?
That would be, it's logical, right? It's logical. Reject the research. The formal languages fail to reject the null.
Okay.
So basically, if you want to be formal, and by all means, if you want to be formal, be formal. I'm not going to crack your knuckles for being formal. You either reject the null with a small p-value, or you fail to reject the null with a large p-value. And statisticians get really upset when you say, I accept the null hypothesis. What? You can't accept the null hypothesis? I give them credit. You really technically can't because you don't know where this curve is. But I say baloney. If you're throwing this one away, this is the opposite. So if you're not believing this, you have to believe this. So this is where a non-trained statistician, like the punk statistician, is like, dude, this is why I say it in English. I believe that from 0 to 1 hour, lung function parameters have been decreased. Boom! Don't use the words null and research and reject or fail. Just say it in English. The data shows that we're 95% cut. You want to use those words, you can. But it appears that lung function parameters have been decreased. And the only way I'm going to have you guys do this for the first couple times we do this is I actually have the entire conclusion written out and you circle appears or does not appear. And that gets you trained to kind of thinking of it as far as it. So I would put it for this one, it, parentheses, appears / does not appear, that lung function parameters have been decreased from 0 to 1 hour. And you'll just circle it appears. And then for the next one, it'll say the exact same thing, appears, does not appear, from after 3 hours. And then you would put it does not appear after 3 hours because it doesn't look like anything's happening after 3 hours. But you could be wrong, right? If you land here, there's still a chance you're down on this curve. There's still a chance you're down on this curve. As one final thing I want to mention, the difference between 95 and 99 or 90% confidence, whatever it is. So essentially, I'm going to break this down. Let me erase as much of this as I can for now and just focus on the right and wrong regions, if that's okay with you guys. So we'll come back to this too if this doesn't make sense. Let's take some of this stuff out. I'm going to try to make this as straightforward as I can. I know it's not straightforward. It doesn't feel that way. It probably feels a little bit squirrely right now. So you're going to run a test. You're going to run a test, and you're going to land somewhere on this top curve. Okay? That position occupies not just the top curve, but also the bottom curve. Okay, I think we're okay with that. There's really two curves. They're both measuring the same thing, but their centers are in potentially two different places. What you've essentially done is you've broken the curve into 4 regions. You've broken the curve into this region, which I think we're pretty used to by now. You've broken the curve into this region. Take that away for a second, too. And I think this is Paris's null curve. You've got the believe H0 and you've got the believe H1 kind of regions. Totally fine. But you've also broken this bad boy down into the curves, too. You've broken them into this, and you've broken them into this. And we don't know how big either of those things are because we don't know where the center is. That's the problem. It's down there somewhere, but we're not sure where. Essentially, if you land here and you're correct about your conclusion, that's called a true what? This is a little bit tricky. What's that called? If you land here, you react appropriately, and you're correct. That would be a true negative, wouldn't it? Wouldn't that be a true negative? Explain why. True negative. That's 100% correct. Why would that be a true negative, friends? Let's go back to what react appropriately means. What kind of p-value did you get? Big or small? Big. Who do you believe?
No.
What does the null say?
No change.
Nothing changed. If you believe the null, you say nothing changed, and you're correct. Nothing changed. Isn't that a negative test result? Nothing changed. And you were correct. So it's a true negative test result. Does that make sense? Let's say that again. Let's say that again. If you land here and react appropriately, big p-value, nothing changed. The key word, nothing changed. That's 2 words. Key words. Nothing changed, that's a negative test result. You're saying nothing changed, that's a negative test result. If you're also correct, that means it's a true negative. That means it's a true negative. So this is a good thing. This is a good thing. There's two ways to be right and two ways to be wrong. That's one way to be right. You run the data, you get a huge p-value, you say, what the hell, my data supports the null. Nothing changed. Caffeine raises your heart rate, just like we're supposed to. Does that make sense? Okay. What if you land here? What potentially could happen here? A true positive would actually be this guy, wouldn't it?
It would be a false negative.
This would be a true negative, wouldn't it? Because this would mean something changed. True positive, sorry, yes. I said the right thing, I wrote the wrong thing. It's a true, thank you, Mary, for... Something changed and you caught it. So you said something changed, that's a positive test result, right? Something changed, positive test result, and you caught it. That'll be a true positive. That'd be a true positive. We don't know the chance of that. Why? Because we're down here, and we don't know where that is. Right? You see what I'm getting at here? We know the chances of things up here, 95.5, essentially. We don't know the chances of things down here. We can play with them later, which we will later, not right now though. Fair enough-ish? Fair enough-ish? Okay, let's go back to this curve. What's this right here? Well, let's reverse engineer. Back to basics. Tell me about the p-value you got right here. Small, less than 5%, right? What does that mean? Who do you believe?
H1.
What does H1 say? Something changed. Therefore, what kind of a test is it? If something changed, it's a positive test result. So it's a positive. It's a positive. Okay? But if we're wrong, if we should be on this curve and we have a positive, that's a false positive, isn't it? If we're supposed to be on this curve, it's a false positive. If we're supposed to be on this curve, it's a true positive. You see what I'm saying? False positive if we're supposed to be on this curve. It's a true positive if you're supposed to be on this curve. Fair enough? And you can see the further out here you get, the less and less chance of a true positive there is. This is why we like 95% confidence. If you start punching into 99, 99.9, 99.999, sure, you're decreasing your chance of a false positive, but what else are you doing? You're decreasing your chance of a true positive. You're increasing your confidence, but you're losing, if you will, confidence here. That's called something else we'll get to later. So we leave it at 95. So what's this right here? What's this going to be right here? What's this going to be right here? This has to be the false negative, right? It has to be the false negative because you're on that curve. You're on the correct curve. And this is the curve that says something happened, but you missed it. So you said it was a negative test result because you said nothing happened, but you were wrong. Because something did happen, but you ended on the wrong spot. So that's kind of the breakdown, if you will, of the two ways to be wrong and the two ways to be right. What do you think we want to do about the ways to be wrong? What do you think? You want to throw them out, obviously. We can't throw them out. You can't throw out parts of the curve. Why would retesting make both of these go down? Why would retesting? Because both of those curves are going to go, which means both of these tails in the extremes are going to shrink down. And I am working on building an Excel spreadsheet for this, and so help me God, before I die, I'm going to finish it. But I'm going to where you can adjust the sample size, and the curves actually do the suck up, and they calculate the areas. It's a pain in the ass because Excel was never meant to do that. But I've got coffee.
They eventually won't touch each other.
Say that again, Georgiana.
They eventually won't touch each other.
They have to touch each other. Georgiana's got a good point. They have to touch each other because where do these tails go? Infinitely. The question, Georgiana, is can we get them far enough apart so that there's an insignificant amount of touch? It's just like when you take Vicodin for after a surgery. You take a Vicodin. That lives in your spine or wherever it lives forever. They have half-lives. Drugs have half-lives, right? They have half-life. After 4 hours, half of it goes away, half of it goes away, half of it goes away. You keep taking half of half, it never goes to zero. But eventually it gets down to such a small amount that it's insignificantly there. That's what eventually would happen with this as well. Now, of course, that's making the assumption you can actually sample infinitely, which is not true, we know. But statistically, meaningfully, that is exactly what we do. Replication of studies serves exactly that purpose. Go ahead, Susie.
So this is the opposite of the fish tank.
So.
Yes, you want to be out of the fish tank here, right? The fish tank are these guys. But the interesting stuff happens when you're out in the tails. Of course, you can also be wrong out in the tails, but you can be wrong essentially anywhere on the curve. The chance is, what you're trying to do here is maximize the time you're right, the chance that you're right. And I hope this picture drives home a point for you guys. I don't want you getting upset about being wrong in this class. Being wrong does happen rarely if you set tests up correctly. Hopefully I've indicated that by the size of the tails. Right? The tails are much smaller. These tails where the falses happen are smaller than the tails with... Picture end pose. Sorry, picture end pose. The tails are smaller than the confidence intervals that they are tails up. And that's the idea, is that you want to build the test to maximize the truths and minimize the falses. And we'll start talking about that more on Tuesday of next week. Okay? Because I don't want to start. I was going to do the card trick experiment as a concrete one, but we got 10 minutes and I really don't think that's
I have a
good.
question. You had said something about you need to retest or do more research. Is that adding more?
Basically, you're increasing the sample size, which pulls the curves.
Right. Okay. I'm hearing two things. Retesting, I'm thinking the same thing, but
You're essentially making your sample size
You have to
larger.
add more to make it.
Exactly.
Right.
That's what retesting essentially does.
Right.
Replication and study.
Not changing, but you're adding.
Correct.
Okay. Just clarify.
You got it. Perfect. Please keep those coming, because that just adds to the conversation. All right. Hopefully this didn't piss you off too bad. Yeah? Maybe we should make a 244 Facebook page and put pictures like that on it. Yeah. Maybe. Because I don't do enough on the line with the friggin' videos now. All right, friends, do me a favor. There's a section called Intro to Hypothesis Testing. It's the next homework assignment down. It doesn't really exist in the text. It's a bunch of like, it's kind of like the articles we read in here, but it's just more of them. Bring questions on that for next time. Okay? Bring questions on that for next week so we can chit-chat about that. Something's due on Monday, or Tuesday, I forget what it is. Is it the quiz? But the quiz is a hypothesis testing quiz, isn't it? Why don't I push that back to Thursday?
Yeah.
Let me do that. Let me push the quiz due date back to Thursday. That was bad planning on my part. That's probably why I did it, was to keep it away from the project, but I think it makes more sense to push it back. Although chances are you could knock the quiz out after you do the homework. Chances are. It's the same as the homework. But I'll push it back. I'll push it back to Thursday. That way you got a project and a quiz due. Just so you know, that project...